Hi everyone, I'm Alex, and I'm an Android Developer Relations Engineer. I'm going to give a quick tour through Insets, what they are, how they impact your app, and how you can use the new Compose APIs to make your apps look their best across as much screen space as possible. Let's first start with the basics. Insets describe how much the content of your app needs to be padded to avoid overlapping with parts of the system UI or physical device features. Because there are different parts of the system UI that may be visible at any given time, there are also different types of insets. These include the status bars, the navigation bars, like the taskbar since Android 12L, the software keyboard, and more. System UI is dynamic, and therefore insets are dynamic as well. How big they are, where they are, and how they change depends on the system configuration and windowing environment. Depending on your device's orientation, which physical screen is showing, multi-window mode setup, or user-controllable settings, insets can change while your app is running. Because of this, trying to use a fixed DP value or querying for an internal system resource to get the status bar height or navigation bar height will lead to awkward extra spacing in the best case, or make components impossible to interact with in the worst case. Instead, handling insets directly means you can make full use of the screen space available to you and improve how your app looks and functions across form factors. You can also update your UI with animations when the insets change, which is especially nice for the software keyboard. Let's see how you can do that. The first two steps are calling windowCompat.setDecor fits system windows with false in your activity's onCreate method, and setting window soft input mode to adjust resize in your activity manifest. Together, these tell the platform that you're going to handle all insets yourself, including the soft keyboard insets. This allows for the most control and flexibility over how your UI is sized and animated with inset changes. The third step is updating the navigation and status bar color to be transparent. This allows the app content underneath to shine through and fill up the full window of the app. Our main tool to handle insets within the app is the Window Insets Padding modifier. This acts like a normal padding modifier, but instead of applying a raw DP amount of padding, it will pad based on the given type of window insets. In this case, it will add the status bars as padding. The available types include all of the ones I mentioned earlier that match up with the underlying platform types, as well as a few safe inset types, like safe drawing. These safe inset types represent a combination of other inset types. Safe drawing, for example, is a combination of all inset types that might visually obscure content. Once you've applied the safe drawing as padding, you'll be safe to draw content without it being obscured by any system decorations. To see why these safe combinations are useful, let's take a look at what happens with multiple window inset padding modifiers. Here, we have an outer box that applies a blue background, and then the status bar padding. Then, we have an inner box that applies a red background, and then the safe drawing padding. Because safe drawing includes the status bars, you might expect that the height of the status bars is added again as padding, but it isn't. The Window Insets Padding modifier communicates with other Window Inset Padding modifiers, and the status bar padding is applied once by the outer box, consumed, and then not added again. Therefore, when we place a spacer, which applies some horizontal padding, and finally a white background, it is adjacent to the blue background from the outer box. The red box didn't end up applying any top padding. When Window Inset Padding modifiers are applied to nested UI elements, they will communicate to avoid double padding. If some portion of the window insets has already been applied by an outer component, it won't get applied again by an inner component. There are convenience APIs for the most common inset types, and you can also get direct access to the raw underlying inset values directly with the type objects, as well as additional information about their visibility and filter out specific sides. All of these values are backed by snapshot state, meaning that they are observable and will cause recomposition upon changing, just like any other composed state. Oh, and did I mention that they're also all automatically animated as well? Let's take a look at that in action for handling insets for the software keyboard, also known as the IME. These are handled in the same way as other insets with the IME padding modifier. Let's apply that to our text field here, which we are placing below a lazy column of items. And that's it. We now have synchronized keyboard animation support. And in case you need to know whether or not the keyboard is visible, windowInsets.isIMEVisible will do just the trick. One more IME-specific control is the IME nested scroll modifier. Here we have the same code as before, but now with the IME nested scroll modifier applied to the scrolling container. This will connect the scrolling gesture to controlling the IME opening and closing on API versions where this is supported. To help with handling insets automatically out of the box, Material 3 components now have built-in inset support. Scaffold, top app bars, navigation rail, and navigation bar have a configurable window insets parameter to adjust which insets they should internally apply. The default insets these components apply is based on where they are intended to be used and the role they play in your app. For example, the top app bar applies the top and horizontal sides of the system bars, the navigation rail applies the start side and vertical sides of the system bars, and the navigation bar applies the bottom and horizontal sides of the system bars, just like we saw earlier. You can see this full implementation of going edge to edge in action in the Now in Android sample. And that's a quick overview of insets and how Compose can help apply them to your app with automatic updates and animations. There are quite a few additional APIs that I didn't get a chance to cover, so check out the docs for additional information about more advanced ways to configure the behavior to fine-tune your app support. If you are currently using the Insets library from Accompanist, check out the migration guide for converting to these new APIs provided out of the box with Jetpack Compose. The learnings from Accompanist have been invaluable for upstreaming these features, so thank you to everyone who tried them out to give feedback. Thanks for watching, and happy insetting.